Hello everyone, I am Mrs. Sayyida Fahmina from Ahmad bin Majid Private School. This video is about topic 11 alcohol objective B1 11.1 B1. Classify alcohols into primary, secondary and tertiary by oxidation reaction. At the end of this video, learners should be able to recall the chemistry of alcohol in the following reaction. Classify alcohols into primary, secondary and tertiary alcohols by oxidation reaction. Important terminologies used in this topic: condition necessary for oxidation and to solve different exercises based on the topic. Chemistry of alcohols. Alcohols undergo many reactions with different reagents to produce different organic compounds. Here I will discuss the first reaction, that is the oxidation to carbonyl compounds and carboxylic acid. Oxidation reaction of alcohol. This slide looks at the oxidation of alcohols using acidified sodium or potassium dichromate solution. Sodium or potassium dichromate act as an oxidizing agent. This reaction is used to make aldehydes, ketones and carboxylic acid, and as a way of distinguish between primary, secondary and tertiary alcohol. So what is the benefit of or advantage of oxidation reaction? We can get or we can form aldehydes, ketones and carboxylic acid, as well as we can distinguish primary, secondary and tertiary alcohols on the basis of oxidation reactions. Oxidizing the different types of alcohol. The oxidizing agent in these reactions is normally a solution of sodium or potassium dichromate Na2Cr2O7, or you can use K2Cr2O7 acidified with dilute sulfuric acid. So the medium should be acidic. If oxidation occurs, the orange solution that contain dichromate 6 ions reduced to green solution containing chromium 3 ions. It means that if the solution is orange, it means the chromium oxidation state is 6, and after the reaction when it will turns to green, the chromium oxidation change to 3. Primary alcohols can be oxidized to either aldehyde or carboxylic acid depending on the reaction condition. In the case of formation of carboxylic acids, the alcohol is first oxidized to an aldehyde, which is then oxidized further to the acid, means carboxylic acid. Partial oxidation to get aldehydes. So what are the conditions to get aldehydes? An aldehyde is formed if an excess of alcohol is used and distill off the aldehyde as soon as it forms. The excess of alcohol means that there isn't enough oxidizing agent present to carry out the second stage. Removing the aldehyde as soon as it is formed means that it doesn't hang around waiting to be oxidized further. For example, ethanol oxidized to ethanol and water. This oxygen means oxygen from an oxidizing agent. So what you will observe in oxidation, as you all know that oxidation means addition of oxygen and removal of hydrogen. So here two hydrogen, one from OH group and one from the OH bearing carbon, both hydrogen will remove and they will form aldehyde. Partial oxidation, as I told you, that will form aldehyde, and full oxidation to carboxylic acid. It means that when this happens, an excess of the oxidizing agent. In my previous slide, I discussed the excess alcohol. Now here an excess of the oxidizing agent is used, and make sure that the aldehyde form as the halfway product stays in the mixture. The alcohol is heated under reflux with an excess of oxidizing agent. When the reaction is completed, the carboxylic acid is distilled off. The full equation of the oxidation of ethanol to ethanoic acid is ethanol will get more oxygen from oxidizing agent and directly convert it to carboxylic acid, that is ethanoic acid. Alternatively, you could write separate equation for two stages. First, ethanol form ethanol, and then ethanol will change to ethanoic acid. So this is what is happening in the second stage, addition of oxygen. Secondary alcohols are oxidized to ketones. For example, heating the secondary alcohols propane 2-ol with sodium or potassium dichromate 6 solution acidified with dilute sulfuric acid formed propanol. There is no such hydrogen unlike primary alcohol, so there is no further oxidation under normal condition. Like in case of primary alcohol, first we got aldehyde and then carboxylic, but in case of secondary alcohol, only one product is formed, that is ketone, and ketones cannot be further oxidized under normal condition due to the absence of hydrogen connected to the carbonyl carbon. Here we don't have any hydrogen directly connected to the carbonyl carbon. Tertiary alcohol aren't oxidized by any oxidizing agent. What is the reason? Here this carbon, that is very important because it bears OH group, has two hydrogen. In secondary it bears one hydrogen, but in case of tertiary alcohol there is no hydrogen. So there is no hydrogen attached to this carbon for the oxygen to remove, so there is no oxidation in tertiary alcohols. Practice questions and answers. It is possible to get two different products from the oxidation of ethanol, ethanol CH3CHO and ethanoic acid CH3COOH. To get ethanol, an excess of ethanol is heated with potassium dichromate solution acidified with dilute sulfuric acid, and the ethanol is distilled off as it is formed. To get ethanoic acid, ethanol is heated under reflux with an excess of potassium dichromate solution acidified with dilute sulfuric acid. When the reaction is complete, the ethanoic acid is distilled off. Write equations for the two reactions. You can simplify these by writing the oxidizing agent as O. So first, ethanol will get oxygen or oxidize to ethanol, and in second step ethanol gains more oxygen and directly converted to ethanoic acid. We can write two times. First you can write this one and you can also write this one for second question. Another, explain why you get a different product by changing the condition in the way described above. To get ethanoic acid formed, you need an excess of oxidizing agent. To make sure that there is enough to oxidize the ethanol form at the halfway point to completion, that is why you heat under reflux with an excess of oxidizing agent. To get ethanol as the product, you need to prevent the second stage. So we will use very less amount of oxidizing agent and more amount of ethanol, and boil off ethanol as soon as it forms so that it can't be oxidized any further. Draw the structure of the product if you oxidize butane 2-ol using acidified potassium dichromate solution. So now we have secondary alcohol, and you all know that when secondary alcohol oxidize, the product will be ketones. Why would you get the same product in the last case whatever condition you use? The product butanone isn't oxidized by acidified dichromate solution. There needs to be a hydrogen attached directly to the carbon next door to carbonyl bond in order for further oxidation to take place. So whatever condition you use, you can't get any other product as carbonyl group doesn't have any hydrogen connected directly to it. Good luck. Thank you.